or once the network sees that transaction, it will run that contract. The contract also contains the amount of ether that you want to use. So the larger the contract is, the more computational steps it takes, the more ether it uses. The idea here is that we try to track the amount of computation exactly with the amount of currency we use. Keep it on par. So how will you interact with this? From an end user's perspective, we'll have basically like a web browser that will be backed by the blockchain. Mist is the target client. And it'll allow you to build applications just in HTML and JavaScript that can interact with these underlying contracts. So, yeah, in conclusion, like Ethereum can be used to codify, build contracts, trusted logic, and secure almost anything. So, yeah. And yeah, does anyone have any questions? Or is like,
can you give one use case kind of to sort of pull it together, because it seems a bit abstract?
Sure. One good use case would be identity management. Right, so in the decentralized web, we talked a lot about like how do we load resources, right? But like another question is how do we do things that need computation decentralized, right? Sometimes you need little pieces of logic to run, right? And everyone needs to agree on the state of what comes out of this computation. That's what Ethereum is good for. So, for example, in reputation, if I give you an upvote and you give someone else an upvote, like everyone paying attention to this reputation system needs to agree on the state. And certain logic needs to happen. You know, intermediating the reputation metric in the database or whatnot. That's what Ethereum will handle. Does that make sense?
Can you be more, like maybe, but I'm still lost.
Okay.
Like, I mean, I'm an expert in digital identity for like both enterprise and aspiring user-centric systems, and so what you said still can help me understand what you do relates to that conventional world of my practice.
I don't know a whole lot about the conventional world.
Right.
But,
but I mean, I'm still
I'll
trying
try.
to make a bridge between what you're saying and what I know, and really trying to listen. So if you could try another example or extend the one you just did, that would be great.
Sure. So Ethereum handles the logic. So
The logic of...
when you rate, okay, so I'm assuming a reputation system like you have attached to eBay market, right? Where people can rate users and give feedback.
Sure.
When you rate a user, you have to increment their, global reputation, right?
Sure.
Well, I mean global, their overall reputation.
Yeah.
So that logic, the part that takes the average of all the reputations they have before, moves it up. That needs to do that decentralized. No central server, that needs to happen somewhere, in some platform.
Okay.
So that's like the kind of computation we do. Another type of, another example is just a simple subcurrency. Like you could implement Bitcoin in 10 lines of code. Actually, yeah. So this is how you would implement, for example, this code on the back of my shirt is how you would implement a subcurrency. So in little amounts of code, you can implement a lot of different things. The logic involved in the subcurrency would have to keep track of accounts, right? Who has what in what account. And when you send some currency to someone else, that account needs to be decremented and the account you send needs to be incremented. And that's the kind of logic it runs. Does that make sense?
Mm-hmm.
So what is the underlying mechanism that allows for this decentralization?
So to agree on the state of the state, we use a blockchain.
So like Bitcoin.
Yes, like Bitcoin.
What fuels it? I mean, Bitcoin has a incentive to create blocks by issuing coins.
Right. So Bitcoin, there's sort of an analogy slightly. You say Bitcoin's sort of like gold, right? It's a scarce resource that has some made-up value, right? And that's why miners are buying blocks, apparently. So Ether has an equivalent to this. It's called, Ethereum does. It's called Ether, except it acts more like digital oil or digital gas because it funds the running of contracts, but it also has some monetary value, and that's what miners get for running these contracts is the amount of ether that was spent running the contract. So, for example, if your contract takes 500 ether to run, because each computational step costs a little amount of ether, right? Whatever miner runs that contract, mines block, gets the 500 ether, plus an award for mining the block.
What can they do with that then?
Well, they can run the contracts, or they can sell it.
Okay, can I ask a personal question?
Sure.
Why do you find this appealing?
I was I was interested in identity. Identity is sort of like a big issue that could, I think, have a lot of interesting applications. But I didn't want to have a centralized identity system. So I was sort of working on a blockchain that just did identity, or reputation and identity, I should say. And then I saw and read the Ethereum white paper, and that I realized generalized the problem. So you could easily build identity reputation systems inside of it with minimal amount of effort. And that was a much more elegant solution, I thought.
So, in terms of how, it feels like there's another conversation to have later about identity, so I won't bore everybody here with that. But in terms of how do regular people end up experiencing this, where is the focus within the community on user experience or understanding that?
User experience. Right now, we're focused on pretty much building like the core technology, and we'll probably focus a little bit later on like UI and UX.
I just say that's really scary in one way because I feel this is typical of many open source projects, and so far their track record of high usability for end users that are regular people is low. Right?
Sure,
So,
that's a legitimate criticism, I think. Right? Like, but Bitcoin has been fairly successful with very low usability and with like pretty crappy UX and UI, right?
And I think that Ethereum is really an underlying sort of distributed database system, as I understand it. It's trying to be a real end user app that people are going to be, oh, now I'm going to pull up Ethereum.
Right.
Is that true?
It's basically a
Yes.
massive computer implemented on the blockchain.
Yeah, it's a single computer. It's a
It's
single
one-
worldwide computer that once we start, like, no one will be able to shut down our sensor. So what you do on this computer is up to you, and also up to you to build the UI and user experience. Like, this is probably more on the level of, in the future, I think this will be more on the level of TCP/IP, almost. Yes.
It's not clear to me in what is Ethereum trying to solve, what problem in the blockchain that Ethereum is trying to solve.
The problem of what? Blockchain?
If I say compare Ethereum, So
Ethereum
from
is-
what I'm hearing right now, it's like it's the evolution. It's blockchain 2.0, right? So what are the issues that Ethereum is solving?
Trusted computation.
When you say trusted, what do you mean?
You need some piece of computation to run that you don't want to trust anyone or any one server that you want to happen decentralized. That's what I mean. Some piece of so there's computation you can do on for a website, let's say, on the front end on your browser. There's some stuff that needs to happen on the server, right? The stuff that happens on the server generally happens there for either security reasons, because it needs to be trusted, right, at some point. That's the kind of logic that we're targeting. We're trying to decentralize.
Okay. That was helpful as an explanation. Thanks.
I don't usually manage the trust and privacy issue. I assume that most people at Amazon don't look at that server or go into some of them probably do, but they're not going to talk about it. But if it's distributed on everyone's machines, I assume whoever is running on the machine can see what's going on. If they look at that.
Right. So you can't be anonymous by default, right? You can build an anonymity on top of it. And I guess by default it's pseudo-anonymous as far as you can't, in the same sense that Bitcoin is, where you're sending transactions from addresses to addresses, but they don't have any intrinsic.
The process isn't anonymous.
Correct. The actual code being executed is not anonymous. It's bytecode. Everyone can read the bytecode. But no one can manipulate the bytecode, right? Like after you put a contract on the blockchain, it's saved there. And someone can't like insert malicious code into that.
So how do you know they didn't? Does it end up running on multiple machines? Can you compare? Does that get-
Yes. That's exactly how it works. All the miners run the same computation. And if a miner like tweaked the computation some form, like their blocks would get rejected.
So, I mean, it's interesting that what you just said makes me wonder about actually, the privacy and security implications, right? Because if you're doing all of these transactions in public, everything that one particular account does can be seen, right?
Absolutely, yeah.
And really weird things start to happen if you force everybody to have all their transactions in public.
Right. As I said, that is an unsolved problem. Like, how could you make this also a totally anonymous system? Like, there's some crazy ideas around ZK snarks, but that's still moon math at this point. But yeah, I think that's an interesting unsolved problem. It is a pseudo-anonymous though, in the sense that you don't know who owns what account. You can just see these accounts. And you can always generate a new identity whenever you want.
So do you envision this kind of, for people who don't need their stuff to be secret, this kind of replaces Amazon Cloud and all those things? Because you now have, it's little virtual machines almost that you're shipping out there for virtual currency and having jobs run for you.
Yeah, well technically it's a singleton virtual machine. It's one virtual machine. Yeah, I think it could replace a lot of
Do you
back...
need the data flow between all processors running?
Huh?
The data flow, there's data flow between each of the subroutines or pieces that get parsed out. That would make it a single machine.
Yeah. Yeah. Well, it acts like a single machine. I mean, it's a distributed system, but it acts like a single virtual
See,
machine.
it's interesting. So it's really just a giant centralization engine. Right? Like back to our polarity on the wall.
Okay, so it's decentralized in the sense of infrastructure, right?
Yeah.
But in the sense of like platform, it's a centralization in, or maybe unification.
It's more resilient, not hackable. You're trading your privacy for it not being hackable. Some 20 jobs out
Right, or actually every miner has to run every single transaction. So it could be like way more than 100, hopefully thousands. People will be running each process.
So, but, okay, so anyways, I'm just really worried about burning up the earth for crazy
Right.
duplicative purposes.
So mining is bad, right? So like mining is probably the most process intensive thing involved in here. And yeah, I agree, mining is bad, and we would love to replace mining with proof of stake or some other Byzantium system. But that's not ready yet. It is in the plan, but we want to launch like the first blockchain. We want to launch our blockchain first, and then iron out any bugs might happen, and then later iterate and switch to proof of stake, which involves a lot less computation.
Okay, cool.
I was going to say, I have this visualization now of basically the whole planet is a Turing machine, and the blockchain is your cake, and
Yeah.
everyone is like punching along and then ka-chunk, instead.
Yeah, I kind of like that.
Because really, what's not clear to me is how the miners end up either cooperating or competing, or is it either or is it both?
Well, it'll work the same. Mining is really a stopgap until we can figure out a better system to come to consensus, right? So mining, as it stands now, will operate similar to the way it operates in Bitcoin. And what we see in Bitcoin is both. Like miners cooperate and form pools, and they also these pools. So we're targeting GPUs, mining on GPUs. Should make it a little bit harder to form pools, or more expensive to form giant pools. So the hope is there'll be more people, individual people competing, so there's less centralization of mining than Bitcoin. The problem with Bitcoin is it uses a really simple mining algorithm. It's really easy to make application-specific intermediate circuits for. Right? These circuits just do one thing, mine. And then someone rich can buy like $1 million worth of these circuits, and then have a large chunk of the transactions. Just maybe not that good a thing, right? If you're trying to build a decentralized system.
Going back to your example of the identity thing, if I'm going to thumbs up Bosco, right, and then one plus and I have one minus or something, whatever, so that there's some account type thing. Would the current state of our totals be in the blockchain?
Yep.
So anybody could go and look for it to go and find out what the global consensus is that my thing is. So if you were going to farm that out to a bunch of players, miners, to go and do this computation, they compete to try to do it accurately, you're going to bring them back and go and find out, did everybody match throughout the outliers. What does matching mean? Matching means the change of state in the blockchain. Is the end state changing what's in the blockchain?
Right.
And if so, isn't that going to be a huge amount of data in the blockchain?
So we actually don't store, we only store the transactions in the blockchain, right? And then you play the transactions, like the blockchain is like a tape, right? You play the tape, and at the end of the tape, the last block, you'll have the current state that everyone agrees on.
Like what his account number is and my account number is, that kind of thing? Those will be actually in the blockchain itself.
The transactions will be. So you send a transaction saying, rate them, give them a plus up, right?
Yep.
And then a year later, he rates someone else, give them a thumbs down.
Sure.
Right? If you replay all those transactions,
you can figure out what people's accounts are.
Right, you figure out the state. So you don't actually store the whole state in the blockchain. You only store the state changes in the blockchain.
And so the computation at the end of the day, when somebody reports back, a miner goes off and takes a pile of contracts to go and do. Then they come back and they say, okay, the result of this is these transactions I want to add to the blockchain?
Yeah, the miner will report back, here's the transactions, and this is, we have state hash, which, so after we change the state, it produces a new hash. So this is, here's the transactions, here's the state hash. Other miners will validate it, they'll check, okay, I'll run these transactions, does he have the correct state hash? If it does, it'll accept the block. If it doesn't, it'll reject the block.
Okay.
Is that
Yeah. Trying to just figure out how to use, and I see how it's used for Bitcoin. Trying to just see how it can work for other.
So, like, Bitcoin uses the blockchain to come to consensus on just the balances that everyone has. We're using the blockchain to come to consensus on the state of a virtual machine, really. A giant virtual machine.
But you just don't store the state in the blockchain.
We only store the state changes in the blockchain.
So anybody that's going to want to figure out what the current state is going to have to run everything themselves.
Interesting thing. Well, no, the interesting thing is, do you know how light clients work in Bitcoin?
No.
Okay. So the interesting thing is we store the state in something called a Merkle tree. So there's ways that a light client can figure out what state changes, figure out what accounts it's interested in, what contracts it's interested in, and then only running the transactions that affect that account or contract.
Okay.
So yeah, there's ways to make it. If you're not a validating node, if you're not like validating all the blocks, there's ways to have the link to run only a few contracts. You have to only run a few.
What's the current state of the, say, of the company, of the technology? Where are you guys?
We have most everything running. Right now, we just went through a security audit, so we're fixing some security flaws in the main client, and we're working on networking code. We're adding encryption to networking, some other details like that. But as far as like the virtual machine and mining and everything else, all the core things. It's just like tying up loose ends.
How many people is it?
That's a good question. I'm kind of, I don't know, maybe like 20 people, 30 people, something like that. It's pretty a decentralized company, and we're spread out all over.
Yeah, and I guess there's like a bunch of people is here and another bunch is in Berlin, right?
Yeah, we have a hub in Berlin, a hub in Amsterdam, and another hub in London. So, yeah.
Cool. Thank you so much.
Yeah.
And